Good evening, everyone. Welcome to the week 5 on problem solving session of industrial wastewater treatment. The instructor for this course is Professor Alok Sinha and Professor S.K. Gupta. My name is Manitnam Prakash and I am from IIT Kanpur. Uh, as usual, we meet on every Tuesday from 6 p.m. to 8 p.m. and the link for which has been already shared with you, and the recording of this session is also recording of this session is also uploaded on the YouTube channel, and the link for which has been also shared with you. Okay, na? So if you have any kind of doubt, you can just go back and check those videos. So in this week, there were mainly discussion of coagulation, precipitation, and heavy metal removals. So we will be looking into some. We will be looking into the problem session will be in two parts. First, there will be a recap of 5 to 10 minutes. I won't be going in the detail. Just a brief recap, topic wise, and then based on those top discussion, there will be some questions. So there are around 10, 20, 10 or 15 question, and if you have joined my previous session, I will give you 1 or 2 minutes as usual to solve those problem. So let's start. So this is like simple. We know that industrial wastewater, first is the introduction. We know that industrial wastewater contains suspended solid and dissolved solid. Suspended solid are visual from naked eye. You can see particles. And dissolved, suppose some kind of salt or some kind of contaminant which is in dissolved form, who has a size range of less than 1 nanometer. Okay, na? That is also available. Then and the industrial wastewater will contain both wastewater. It will contain suspended solid also, dissolved solid also, and there will be some colloidal also. Okay, now so we need to remove all these three. If we want to treat industrial wastewater, we have to remove. We have seen how suspended solids are removed. We have also seen some techniques to remove dissolved solids, not all. And also we have seen some. Now in this upcoming session we will be looking into colloidal removal and all these things, but some parts have been already discussed in the previous, like in week 2, 3, 4. Okay, so here coagulation and flocculation is the first topic which was discussed was coagulation and flocculation. Coagulation is destabilizing colloidal particle to enable settling. So if you just briefly recall, simple wastewater, it has nothing to do with wastewater, industrial wastewater. If you look in general how simple wastewater is treated, then we know that there are some larger particle which are removed at a screening chamber. Then it is into the second unit, that is primary sedimentation tank. And in the primary sedimentation tank, all the suspended particles are settled, but there are some particles which cannot settle. It will remain suspended. So there are several reasons. One of the particular reason is that their weight is very low, so that's why it remains suspended. So somehow if we increase its weight or do there are somehow if we increase the weight of particle, there are chances that it will precipitate or it will settle down. So for that, we add coagulants. Once a coagulant are added, so what will happen, that process is known as coagulation. So there is like we add something, and what will happen that there will be some charge difference. Some There will be some charge some property will change. So what will happen that one particle will start uh, other all the particles will start to form a kind of agglomerate, and that is known as flocks. Okay, now like smaller particles are getting attached by some kind of electrostatic force or anything. Then what will happen that its weight will finally increase and finally it will settle. Okay, now so first there will be addition of chemicals, then there will be formation of flocks, and finally it will be settled. Okay, now increase the particle size by aggregation of each for easier removal. So remember, all these process occur simultaneously. First there will be coagulation, then there will be flocculation. Type of flocculation is microflocculation, also known as Brownian movement. We know that dissolved ions show this kind of movement, Brownian movement, randomly zigzag. Then micro, that is mixing included. Okay, now so we need some kind of mixing in both the process in coagulation and flocculation. Okay, common coagulants are alum, ferric sulfate, polyaluminum hydrates. All Every coagulants have a particular pH range. For example, alum will work in the waste will work in the pH range of 5 to 7. Similarly, there will be ferric sulfate. Similarly, there will be polyaluminum or iron chloride. Every coagulant have advantage and disadvantage that you should know. Factor affecting coagulation and flocculation are particle size, charge. 1 minute, sorry. Sorry. So, so what I was saying, I hope you are able to see my screen. Yes. So these are some of particle size and charges. So a smaller, highly charged particle resist. So a smaller size it will have less weight. So what will happen that its weight will be very low, it will remain suspended. Highly charged particle also resist coagulation. So like suppose uh, generally when two particles like forms a heavy particle, the main force is charge. Now imagine that there is a particle which is highly charged, and it will, what will happen that it will try to remain independent. It won't it, there will be huge repulsion from other same charged particles, okay now. So that can also affect coagulation. PH and ionic strength, what are different components in the wastewater, that also a pH. Like I said, you, every coagulant has a particular pH range. If you have added coagulant and the particular pH is not maintained, then your aim will not be fulfilled. Kinetics, temperature, like higher temperature, more coagulation and flocculation. This is it depends on many things. Shear force impact floc formation. So if you apply high shear, high mixing, so that's why I missed one thing, that in coagulation there is a rapid mixing. In coagulation there is rapid mixing because we want proper distribution of all the coagulants added, so that all the particles which is there can interact in a proper way. But during flocculation there is a slow mixing. Why? Because we want flocks to forms. Well, if and only if flocks will form, then flocculation will occur, okay now. So if we apply too much mixing, then we are applying too much shear force, so what will happen that the flocks formation won't occur. So that's why it is said that mixing should be very low. Particle solvent interaction, these are some of the other. I told you now, all these flux formation solely depends upon electrostatic force, and some of the forces are van der Waal forces, electrostatic interaction, hydrogen and steric stabilization, surface charge formation. So these, some of these things has been discussed to you in a very brief, very detailed way in your lecture, so I'm not going to discuss this thing here. Mechanism of, so like see these are certain mechanism. Like there will be first charge neutralization. Suppose initially all the particle was say suppose positively charged. So if all are positively charged, so say negatively charged, okay now. So what will happen that this will to need to repel each other. Now imagine that uh, if you remove the charge, so what will happen that it will, due to some other force, it will form a larger particle, okay now. So that is known as charge neutralization. Once charge neutralization occur, a larger particle will form and it will precipitate. Second is that, let it, I don't want to neutralize the, so there is a polymer bridging. So what will happen that suppose there is one particle, there is one particle, there is another particle. So I will add one polymer, okay na. So if we add the polymer, so what will happen that polymers are very long chain, long, it's like long carbon chain, okay na? So what will happen that this polymer will bind all these particles and will make a heavy particle, and that will settle down. And third is swift flocculation. Like what will happen that like swift flocculation, trapping of particle, precipitating low, we will precipitate something. So now suppose there is, suppose imagine that these red dots are a smaller suspended particle. So if we, what will happen that if we form a larger particles, precipitate a hydroxide, say suppose which is in larger side. So what will happen that it will start to settle down. So once it will start settle down, it will also take the smaller particle along with it. So in this way we will be getting clean water, okay now. So these are some of the mechanism of coagulation. Precipitation in wastewater. So this thing I was saying that LM waste pH range for LM is 5 to 7. Iron precipitation occur at 7 to 9. Lime precipitation for hardness and phosphorus removal. This method has been discussed, like how lime precipitation occur, and then how alkalinity is removed, and how uh, presentation is not visible. What about others? Just let me check 1 minute. Please respond. Anyone? Other? Is everyone facing same problem? Now visible. Okay. Just 1 minute. I hope everyone is able to see my screen. It is in presentation mode. If anyone is facing any kind of problem, please let me know. Now, I hope this is okay. Then heavy metal removal. So there are several method for see. Yes, it is visible. So some of the common are cadmium, lead, mercury, chromium, zinc, nickel, copper. So uh, what happen that generally we add some kind of chemicals. So what will happen that it will form a precipitate and it will remove from. For example, I will explain you about chromium. How chromium is removed. So chromium generally what is normally uh, there are two form of chromium. Okay, na two form of chromium, that is chromium 6, chromium plus 6, and then there is chromium plus 3. Okay, now so this chromium and the total, there is a limit of total chromium in the drink. I'm just talking in a normal way. Okay, now so there is some discharge limit also, but I don't remember the discharge limit at how much chromium can be discarded from one industry, that you can see at the CPCB. But for drinking water, the maximum limit is 50 microgram per liter. Okay, now it should be less than 50 microgram per liter. Total chromium, micro, remember, mu g ppb, that will be also called 50. Okay, now and there is no limit for chromium. Your water should not contain any kind of chromium 6, because chromium 6 is very carcinogenic in nature. That if you drink it, it will certainly cause you cancer, not in a short moment but after a long time. Okay, now so generally what happened that suppose there is a water contaminated with chromium 6. So what will happen that generally we add chromium iron 2 salt, iron 2 salt in the form of say FeSO4. Okay, now so what will happen that if if you add iron 2 plus in chromium 6 contaminated water, so iron 2 will get converted into iron 3. Okay, now and this chromium 6 will also get converted into chromium 6. Okay, so what will happen that iron and chromium will form a co-oxy, and in presence of water what will happen that they will form a precipitate, and the precipitate is known as iron 3 chromium 3 co-oxy hydroxy precipitate. Okay, now so what will happen that, and that precipitate is very heavy, and with time it will settle. So in that way the chromium, this is just a brief how chromium is removed. There are other example of lead removal, and many things. Okay, now so and the how much salt should be added all depend upon the solubility product. So there is, suppose there is one, suppose I want to remove metal M. So uh, uh, we will discuss how what is this KSP and all this thing now. Okay, now so generally hydroxide precipitate pH dependent. Then we have sulfide precipitation form highly soluble sulfide. So if there is some metal, and some metal have very high affinity towards sulfide, so what will happen that that metal will combine with sulfide and a sulfide precipitate will form. Use of organic complexing agent also. Okay, so this was all about. There is one another phosphorus removal. These are some of the topics. I think I have already taken 20 minutes, so I will just go into the problem solving session. So this was about metal removal. Then we have phosphorus removal. There are two process, like we can add calcium or we can add alum. Both topic has been discussed to you. Okay, na so. And then there is a sludge generation, sludge from precipitation calculation method based on efficiency. So like we have to mm, uh, handle the sludge also. Okay, now then there are other method of heavy removal method, such as adsorption. We will use some kind of adsorbent, and that adsorbent will remove. For example, in case of arsenic removal, suppose your industrial wastewater is contaminated with arsenic, so what will happen that people use iron iron rod, zero valent iron. There is one like nails and all these things, because in that nails and all we have iron in zero valency, so that why it is known as zero valent iron. So when arsenic is passed through those water, so arsenic get adsorbed on the surface of that nails. So in simple, in technical word, we don't say nails, we say ZVI or zero valent iron. Okay na. Then we have iron exchanger. We have already discussed in previous two, I think, previous session only. What is this ion exchange? Then membrane filtration, reverse osmosis, nanofiltration, then electrochemical method. Okay na. Bioremediation, use of bacteria. So there is some phytoremediation, like for example chromium. In case of arsenic also people are using bioremediation. For chromium also people are using bioremediation. Like there is one study going on where people use this bacteria to like convert the chromium in some another form, and where from industrial it is removed. Okay, so this was all about a small recap. If anyone have any doubt, you can ask now, or else we will go to the question answer session. Okay, then this is first question. Flocculation refers to, I there are eight people, seven people. I request request everyone to please participate. Write in chat box what will be the answer. Box is open to everyone. Uh, yes, chat box to is open to everyone. See, we got first answer. Process of bringing particle closer to each other. We got two C. Okay. Yes, the correct answer is C. The process of bringing particle closer to each other. Flocculation is process in which destabilized colloid particle aggregate or clump together to form a larger particle stable flocks. This process occurs due to the addition of flocculants, which add in formation of bridges between particles, leading to their aggregation. Flocculation is commonly used in water and wastewater treatment to enhance the sedimentation and filtration of suspended particles. So remember the whole process, that first coagulation will occur, and to add the flock formation or to precipitate, then there is uh, there is addition of flocculants also. So this coagulation and flocculation occurs simultaneously. Okay na. So this is not just general to industrial wastewater. This is common to every kind of wastewater. In even in case of yes, it is common to every wastewater. Why other option, destabilization of incorrect. Destabilization of colloidal particle is separate process known as coagulation. Okay na. Remember, we are destabilizing. This term is little bit of confusing, that how we are destabilizing the colloid particle. Whenever we talk about destabilizing, so remember the particle which was there in the suspended form was a stable particle. By addition of coagulants we are destabilizing. That's why the process is known as destabilization. Okay na. Some kind of salt such as Al2SO4 or ferric chloride are added to neutralize the surface, or there are several processes that occur simultaneously, and finally flux will occur. Okay na. Adsorption and charge incorrect. Adsorption and charge neutralization are mechanism are involved in coagulation, not flocculation. During coagulation, coagulants neutralize the negatively charge of the colloidal particles, allowing them to close. So this is already we have discussed that it will come closer, it will form heavy particle, and finally it will settle. Then settlement of flocks incorrect. Settlement of flocks, once the flocks are formed, then will be simple sedimentation, and all the formula which we have read about sedimentation. If anyone has already done wastewater course, then there we have discussed how what is the settling velocity and all these things. Once the flock will form, everything will be in the normal form. Okay, flocculation refer to this we have. Second, this differential settlement of particles having different size leads to. See this thing, B we got macro flocculation. B. Hmm. Yes. Generally, there are two things, that is equanic Brownian movement, that is known as micro with I, and in case of larger particle, we have macro. Okay, na? Just, The correct answer is B. Differential settlement of the particle of varying regions occur because larger and higher particles settle faster than the smaller ones. This type of leads to micro flocculation, where larger particles are formed due to varying settling velocity of different size particles. This process enhance the sedimentation efficiency in water treatment. Okay, now this refers to the initial aggregation of very fine colloidal particle into small flocks, usually due to Brownian movement or slightly fluid movement. It does not involve differential settling. Charge neutralization is a mechanism involved in coagulation, where chemicals neutralize the electrostatic repulsion between the colloidal particle, allowing them to come closer. It does not describe the process of differential settling. This is little bit lengthy question. Just read it, take your time, and write. You can write the answer in chat box. Which of the following statement is or are correct regarding particle solvent interaction? Electrostatic interaction can attract or repulse depending on the charge of the particles. Van der Waals forces are a strong attractive forces that rises from. Here it is third point. Okay, now I just forget to mark inter. Now it is okay. Hmm. So here you can see, there are four option out of four statement, and you have to choose option A, B, C, D. Like so, first, so like these are some of the general question. You don't have to like even if you haven't gone through the lectures, you can answer it. Static stabilization occurs when a layer of adsorb, such as polymers or surfactant, creates a barrier that prevents close approach or aggregation of colloidal particles. A specific interaction such as hydrogen bonding or chemical bonding can occur between colloidal particle and certain solvent. Anyone with any answer? A, B, C, D. We have got C. One answer C. 1, 3, and 4. Yeah. Actually, this was very simple question. Also, only if you know this about van der Waals forces. Van der Waals forces are very weak forces, not very strong forces. Okay, now so this will won't be answered. This won't be answered. This won't be answered. This will be our answer. Okay, so yes, correct answer is C. Statement one correct. Electrostatic arise due to charger on colloidal particle. If the particles have like charges, they will repel each other. If they have opposite charges, uh, they will attract each other. Hence, electrostatic interaction can be both attracted, making this statement true. Okay, now Van der Waals forces are weak. Remember, it is very weak, not strong. Okay, now the incorrect statement call them strong, whereas they are actually weak compared to electrostatic, making the second statement correct. Steric stabilization happens when a layer of adsorbed molecules such as polymers forms a barrier around the preventing. So there is a very good science behind it. Steric stabilization. Okay, now I'm not discussing it, and I have also less idea about this thing. But if you have any kind of doubt about steric stabilization, how there is a charge layer, double layer, diffused layer, depending upon this, there is something called steric stabilization. So I request you to go to that lectures, and you can have a detailed idea what is this. This effect to stabilize colloidal dispersion and is correctly described in the statement. Statement 4 is a specific interaction like hydrogen bonding or chemical bonding can occur between colloidal particle and the, so for example, hydrophilic colloidal particle in the water form hydrogen bond affecting the solubility. And so this is also like in soap we know that we have hydrophilic and hydrophobic particles, and what will happen that it will attract, and we know that those soap particle will interact with water only. Depending upon that, we have this uh, what do we call, foam formation. Okay na. So yes, indeed, and the bonding which happened between those colloidal and water or particle, simple particle or water, is just because of hydrogen or some chemical bonding. Okay na. So this was just an example, and correct, this make a statement correct. So find, yes, correct answer is C, 1, 3 and 4 only. Again one lengthy question. Which of the following is a statement is or correct? Okay na. The first is flocculation requires particle-particle interaction, and where the interaction is enabled by, and this interaction is enabled by without the system of external mechanical string. It termed that perikinetic flocculation. Then rate of coagulation of particle in liquid depend upon the frequency of collision between the particle due to their relative motion. When this motion is due to Brownian movement, coagulation is termed as the perikinetic. When the relative is due to caused by velocity gradient, it is called orthokinetic. Orthokinetic flocculation involves the aggregation of particles involved by velocity gradient mixing or the process of differential settling. So go through. We have got one answer, that is C. That is one, two, three. All three are correct. Anyone anymore? Any? Oh, we have got already got two answers, so we will look into the solution. Yes, the correct answer is C. All three are correct. Perikinetic flocculation occurs when particle-particle interaction happens simultaneously due to Brownian motion without any external stimulus. Brownian movement is the random movement of microscopic particles in a fluid which leads to collision and flocculation. Since there is a statement, so remember, due to Brownian movement, what will happen, that a particle will strike each other, and there are chances that it will form say larger particles, and this is known as perikinetic flocculation. Okay na. The rate of coagulation depends upon how particles collide. If Brownian movement causes the collision, it is known as perikinetic, which we have which we have already known. If the velocity gradient or mixing is cause the collision, if we are applying some external force, then that is known as orthokinetic coagulation. This statement explains this concept, so it is correct. Okay. Orthokinetic flocculation happens when the external force like mixing, velocity gradient or differential force, this process is so if you look, all these three part options are just saying in different forms. Okay na? This process is commonly observed in the water treatment plants where controlled mixing is used to enhance the flocculation. Since there is so this is also correct. So yes, the correct answer was C, 1 to 3. Okay now just remember the definition. If it is occurring on, if the flocculation is occurring on its own, it is known as perikinetic, and if some external force is applied for the flocculation to occur, then it is known as orthokinetic flocculation. Hmm. The electrical layer which moves along the colloidal particle when it is subjected to electrical current is known as A. External layer. Anyone? D. We have got electrical double layer. We have got two answer. Anyone? Anyone else with any other answer or supporting these two, A and D? Anyone with any more answer? D. So correct answer is D. That is electrical double layer. External layer is a part of electrical double layer. Okay, now the name itself suggests double layer, and we know that there is two layer in when we talk about this kind of surface it's like this type of potential terms and all these things, that is diffuse layer and a stern layer. Okay, now when colloidal particle is placed in liquid, it develop a electrical double layer or EDL due to interaction of charged surface groups with surrounding ion. This electrical double layer consists of a stern layer, the inner tightly bound layer of counter ions absorbed on the particle surface, and then we have diffuse layer, a more loosely held region of counter ions extending into the solution. Okay, now so suppose we have this particle. So what will happen that around this we will have one stern layer. Okay, now I'm making it random. So what will happen that there will be huge charged particles here. Okay, now it will be highly charged. If it is surface is positively charged, then it will be highly negatively charged, and after that there will be one more layer where the charge density will be little bit less, and overall this is known as EDL. Okay, now E D L. Okay, now electrical double layer. Okay, now so yes, this one my correct, and this is my correct answer. D. I have already given you the reason because there is a formation of this type of layer. Okay, now so depending upon that, there will be a interaction. A stern layer is only the inner part of electrical double layer, does not move at a as with hold the particle. There is no distinct zeta layer term zeta potential. This is another thing. There is nothing called zeta layer. There is one zeta potential. So what will happen that suppose there is like depending upon the potential, your surface will be either positively charged or negatively charged. Okay, now. So suppose say at a particular pH, your zeta potential is say your zeta potential say is 50. Okay, now so what will happen that above 50 your particle will be positively charged, and below 50 it will be negatively charged. So this is just simple. There is nothing called zeta layer. Sleeping plane is a boundary within the diffuse layer beyond which the liquid moves independently of the particle but does not represent the entire moving electrical layer. Okay, now so the sleeping plane is entirely different thing. Okay, now so how it is beyond within the diffuse layer. So there we have seen this is our diffuse layer. It is within this layer only, beyond which the liquid moves independently of the particle. So how we know that due to some interaction electrostatic force, the particle movement, or what we call the liquid movement, will be disturbed or hindered. Okay, so this after certain point this hindrance will be no longer what do we call dominant. Okay, now so that the plane or the point at generally it will be a whole area, that's why it is known as plane. Okay, now so that plane is known as sleeping plane. Again so that answer was D. One person say Valete, you said A. I think you should check the notes. If you have any doubt you can ask, or else let's go to question number 6. The net energy curve for charged colloidal particles so that entry barrier reduce the separation distance between the part as the separation distance between the particle is increased. What may be the reason for no flock formation at such distance? As separation is increased, there is no formation of flocks. So why it is? You must have seen one graph like this type of graph, electrostatic interaction like this, something like this. Okay, na. uh, this is simple electrostatic interaction between, and this represents the distance between two particles. Anyone with any answer? For your I will also show you the graph which we are discussing here. A. We have got one answer A. Let's wait. Just give one moment. Hmm. You can see separation distance and total interaction energy. Okay, na? Then we have Coulombic repulsion potential. Then we have van der Waals, and this is overall interaction between electrostatic van der Waal and including all. Initially, it is in energy is in negative. Then finally, it is in positive. Okay, na? So this is our diffuse layer. This is a stern layer. Okay, na? See here, it is zeta potential. We have a stern potential, nurst potential. So this type of different potential defined depending upon the how you can see here. This is combination of a stern layer and diffuse layer. We have electrical double layer. I hope you all are able to see it. The question was uh, the net what may be the reason. So first is van der Waal forces at that distance are big. Flux may be formed but it can rupture easily. Electrostatic force increases with with separation distance. Electrical dependence may extend within the separation distance. So the correct answer is A, that is 1 and 2 are correct. The net energy curve for charged colloidal particles show an energy barrier that prevent aggregation. As separation increases, the energy barrier decreases, but the flow still does not occur at large distance. The main reason are van der Waals force. Yes, we can see from that graph that a very weak one. So this is my wonder where does it go. So you can see that as distance increases, the van der Waals forces uh, decreases. Okay, now. Similarly, energy related here, it is saying in terms of energy. Okay, na more negative means more attraction. Something. No, it depend upon how is the. Sorry, I might be wrong here. Okay, na I am not able to recall how this is read, but I think this must have been discussed in the lecture. Since van der Waals forces are responsible for attraction and flocculation, their weakness at large distance prevents its flocculation. Hmm. Why it is not happening? Statement two. So even if some flocks are formed at larger distance, they may be can rupture easily due to lack of a strong attractive forces. This at this distance, this van der Waals forces cannot sustain, and that's why what will happen that all the flocks which were has formed will get ruptured. Okay, now electrostatic force decreases. So here it is written that if you recall this, electrostatic force increases with separation decrease. No, it's not that. The correct statement will be electrostatic forces decreases, not increase with increasing separation. This is because charged particles are shielded by coulter ion in the diffuse layer, and the repulsion effect weakened as they move apart. Okay, now then we have fourth statement that is EDL may expand under certain condition, but this does not necessarily prevent formation. Okay, now the key reason for no flux formation is big van der Waals force, not just expansion of ELD. Okay, now so the first two options are correct. That's why the answer was A. 1 and 2 are correct. I hope this thing is clear to you. Then we have a big question again. What is the primary factor influencing the quality of lime required for phosphorus precipitation in wastewater, and how does this requirement relate to the alkalinity of wastewater? Read each and every option carefully and then try to answer it. Anyone? C. We got one answer, that is C. The lime requirement for phosphorus precipitation is primarily dependent upon the both alkalinity and presence of phosphorus, usually falling within the range of 2 to 3 times the total alkalinity expressed as CaCO3. Let's see. A. We got one different answer, that is A. Anyone with more answer or supporting this answer only, that is A and A or C, or any entirely different answer? Anyone else? Take your time. I will give you 1 to 2 minutes. The time. Does it depend upon both, or does it depend upon just alkalinity, or just it depend upon the phosphate? We have got one more answer, A. So let's see the answer. Where does the correct answer is A. The lime requirement for phosphorus precipitation in wastewater primarily depend upon the alkalinity, typically ranging from 1.4 to 1.5 times the total alkalinity expressed as CaCO3. I don't know why you said A, C, but like first of all, is that is not 2 to 3 times. The typical range is 1.4 to 1.5 times only. Okay, na. So we will see. What's then we will look into the other option. Lime, which is commonly used for phosphorus removal in wastewater treatment, the efficiency of phosphorus precipitation depend upon the availability of lime to rise the pH to level where calcium phosphate can precipitate out. Okay, na. And it is generally in the range of, I don't remember the range, but calcium phosphate solid. This can anyone name what is the name of this solid? Ca5PO4 whole thrice OH. What is it is called? Anyone? Just 1 minute. Just try to answer it. Hello? Hel- ek- Hello? Hello? You? हेलो. हाँ हाँ सर बोलिए. हाँ मतलब हाँ है तो. एक्चुअली मैं क्लास में हूँ ना, मैं आपको बाद में फ़ोन करता हूँ. Yes, it is called hydroxyapatite. Remember, generally our bone are made of hydroxyapatite. So, if someone, I hope many of you might know that our bone are made of hydroxyapatite. So generally, that's why this fluoride problem is very, is like, it should be taken in serious. What happened that this phosphorus? this fluoride replace OH, and the it is very like it, it is a very stable form, and it is like what do we call also beak also it is if hydroxyapatite uh, so but will have so this and that cause some kind of problem and all this thing. Okay now, so this is known as hydroxyapatite. So to precipitate this hydroxyapatite, we need a certain pH range. Okay now, and generally it is between 5 to 7. So this for precipitation of hydroxyapatite, the pH range is between the optimum pH range. I cannot recall the optimum pH range, but it is between 5 to 7. So we have to maintain that much pH so that precipitation of phosphate can occur easily. Okay now, the efficiency of phosphorus precipitation dependent ability to rise the pH to a level where calcium can form and precipitate out. Why does lime require depend on alkalinity? Act as a buffer and act as how much lime is needed to raise the pH. In high alkalinity water, the less lime is required, while in low alkalinity wastewater, more lime is required. Okay now. The general estimate is that the lime required is 1.4 to 1.5 times the total alkalinity expressed in CaCO3. I hope this is all clear to you. Just I will go to the lecture notes where this has been explained. Okay, na. Uh, here they are talking about this formation of use of aluminium. Okay, na, how this alum is forms. So can anyone say if you have gone through the lecture why alum is not suggest is suggested not to use? Why for our coagulation purpose we should not use alum? Anyone? It is advised that we should not use alum. This is our phosphorus in water. Okay, na? So multivalent form. You can open the mic. You can just hydroxyapatite. You can say anything. Okay, now when lime is added to water, it reacts with natural alkalinity to precipitate CaCO3. Okay, now A will be. I don't know why it is subscript. As the pH of the wastewater increases, butane, the excess calcium ion will react with phosphate as shown to precipitate the hydroxyapatite. Okay, na? Oh, so I was wrong. The optimal pH is beyond 10. Okay, na? So you can see, and here you can see that it is directly proportional, and it is generally 1.4 to 1.5 times the alkalinity. Okay, na? Then we can also use aluminum. Again, here aluminum will precipitate phosphate. Anyone why alum should not be used? The reason is very simple. Alum itself is a very neurotoxic. Okay, now so if now you are using aluminum for to remove phosphorus or to like for coagulation purpose also. So generally it is said that if the residual so now you have to add now you have to treat also alum. Like your treated water should not contain high amount of there is certain limit of permissible and acceptable limit. I'm talking in the drinking water for drinking water. I have no idea about discharge. So what happened that when we get water, the aluminum concentration should be less than prescribed value because consuming aluminum water exceeding the permissible value can cause neurological disease such as dementia and that kind of thing. Okay, now that's why at many country this use of alum is prohibited. And if they are using it is suggested that please make sure that it is within the drinking water limit. You might many of you have might have heard of Nalgonda technique for fluoride removal. Okay now, so in fluoride removal there also we use lime and alum. So what happened that we when we add I don't know why. So at there also the Nalgonda technique technique is not used for fluoride removal in spite having very high efficiency because there is a leaching of aluminum. Okay, na? Okay, na? So there is a leaching of aluminum which is neurotoxic. So I hope you have got it. The correct answer is A. And just remember the graph. Okay, na? And the typical range is 1.4 to 1.5. Question number 8. When does the coagulant in wastewater containing high suspended solid is increased, the turbidity value decreases, but or further addition of coagulant turbidity may again increase. Reason for such increase is B. Charge reversal. This is based on these. If you miss like based on this concept only, the optimum value of coagulant or flocculants are found out. Okay, na. Now we have another answer that is sweet coagulation. Okay, we have got two answer. Anyone with in more answer? B. Okay, let's see the correct answer. The correct answer is B. Okay, now in wastewater treatment, coagulants such as alum or fluoride are added to destabilize the suspended solid and promote flocculation. Initially, as the coagulant dosage increase, turbidity increase due to effective coagulation. So initially, what will happen that we are adding coagulant, so there will be more colloidal forms, so turbidity will increase. However, if the coagulant is overdue, turbidity may start increasing. Sorry, I told in a opposite way. Okay, now I'm taking my words. Sorry for the wrong explanation. Initially, as the coagulant dosage increases, the turbidity decreases due to effective coagulation. So, what is happening that all the suspended particles or the colloidal which was there will either will forms a larger particle will settle and the overall turbidity will decrease. However, if the coagulant is overdosed, the turbidity may start increasing due to charge reversal. Okay, na? So what will happen that how to explain this? Huh? Why does charge reversal occur? Coagulants neutralizes the negative surface charge of the colloidal particle, allowing them to aggregate and settle. So in this way, what will happen that again your turbidity will start to increase. Okay, now because what is happening that initially there was some charge, the charge has been neutralized, but due to overdose, again the charge has been charge was made unstable. So what will happen that uh, in this way like what will happen that the turbidity will finally increase. Okay, now so I can this thing can be also explained with what do I called one graph is there. I will show you my notes. Okay, now so I don't have, let me show you to how I will be able to explain that thing in better way in through my notes. So this thing we have shared like coagulation. What will happen that initially this thing is happen coagulation pH decline coagulation. No. Here you can see initially what is happening that as initially there was some initial turbidity of our system. Okay, so as soon as lm dosage was increased, so what is happening that uh, what is happening that particle started to destabilize. Okay, now particle started to destabilize means started to forms larger particle. So what will happen that this turbidity will decrease, but as soon as you add more particles, more lm, so what will happen then, it will particle will start to re-stabilize, means whatever there are the flux which was formed, what will happen that it will start like the agglomeration which has happened has will like won't happen, and the particle will remain as it is. So again in that case there will be re-stabilization. So initially it was stabilized, here it was stabilized, then we have destabilized due to addition of lm, and again we have destabilization. Okay now, and this based on this concept, the optimum dosage of any coagulant is also found out, and this test is known as jar test. Okay now, so what will happen that we take several type of beaker, we add the coagulant, we mix it, and we measure the turbidity. Okay now, so based on this concept only, we can know that how what is the optimum, like there will be at point now where there will be minimum turbidity, and after that the turbidity will start to increase. So we can say that after addition of this much of lm, our particle will start to re-stabilize, like particle will start to remain in the suspended form, and that's completely the role of charge on the particle side. Okay, I hope everyone got this idea. The re-stabilize the particle, causing them to repel each other again, leading to an increase in so what will happen that again the particle due to re-stabilization, again the two particle which was there will start to repel each other, collides will increase, leading to the increase in turbidity. Adsorption and charge neutralization incorrect. This mechanism explain the initial turbidity reduction, but it does not account for increase in order. So due to charge neutralization and adsorption, initially there is a decrease in. We know that in coagulation also there is some process of charge neutralization and adsorption. Okay, now but this does not explain why there is an increase. Okay, now so it is partially correct and overall incorrect. Sweep coagulation. Some of you have said C. Sweep coagulation occurs when high dosage of, you can see here in this where does it go? Here you can see that again when we are adding too much of lm, so there is a concept of swift flock. So what is happening that this lm will react with water, it will form aluminum hydroxide, and aluminum hydroxide what will do that it will start to precipitate, and it will also carry down the smaller particles. Okay na, which is there in the system. So overall what will happen that there will be this phenomena is known as shift flocculation, occurs when a high dosage of coagulant forms a precipitate that traps suspended solid, leading to the effective. It does not explain why turbidity increase with excess. Okay, now so this swift flocculation is entirely separate phenomena. This has not, like this has to do with coagulation, but this is not related to the question. Interparticle bridging. Okay, now interparticle bridging happens when polymeric coagulants, where long chain molecules bind multiple particles together. This process does not cause charge reversal and is not responsible for turbidity. So this is entirely another thing. So due to this interbridging, there will be decrease in what do we call turbidity, but due to this, there will be no increase in turbidity. Okay. So we have another numerical question. I would suggest everyone to solve it. Take your 1 or 2 minute time. It is 704. I will wait for. It's very simple question. Just you have to multiply and divide something. Reaction is also given to you. You have to just see the moles and all these things. I'm coming in 1 minute. everyone, please solve it. It is 7-6. One more minute. One. If you want more time, then you can take it. The what will be the amount of alkalinity required for reacting 20 milligram of alum, and at such alkalinity what will be the amount of sludge that will be generated as aluminum hydroxide form. So you can see that this much amount of alum that is we are adding, and alkalinity will be in the form of this thing. Okay now, so just simple, you can see that 1 mole of alum is reacting with 1 mole 3 mole of what do you called this bicarbonate, that is responsible for alkalinity. And also 1 mole of alum is giving 2 mole of aluminum hydroxide as ppt. So just you have to convert 20 milligram per liter in mole, then multiply by 3, then you have to convert into alkalinity as CaCO3, and similarly twice the mole, and then multiply by its molecular weight to get PPT. I think this was very. Oh, I we got one answer. A, 4.5 milligram per liter CaCO3 and 2.34 milligram per liter CaCO3. I think that is correct answer. Okay, na. Let's see. Mm, what is the correct answer? 4.68 and 9. Oh, you are wrong. C is the correct answer. Oh, sorry. D is the correct answer. Let's see where have you made mistake. Okay, now the molecular weight of alum is this much, 66 gram per meter. Molecular weight of calcium is 10 milligram, 100 gram per mole. 1 mole of required 3 mole of which compose 3 into itna per itna. That has the alkalinity is 300 by 666, that is 0.4 gram as CaCO3 per alum. For 20, here I have calculated for 20, for 1 milligram. Then for 20 milligram it will be 20 into 0.45. That is 9 milligram per liter. Did you get it? Why we have 9 milligram per liter? Where have you? How did you make it 4.5? Similarly, here you can see that 1 mole of itna produce 2 mole of molecular weight of itna. 1 mole of aluminum is itna producing 2 into itna gram of aluminum hydroxide. For the given amount, this much aluminum hydroxide per mg of the alum, and for 20 milligram 20 into 0.234 or 4.68 milligram per liter of aluminum hydroxide. There is another way to solve this thing also. I have missed, like, let me show you another method also. Here you can see they have directly multiplied it by 20 into 3, because we know that 3 mole of aluminum hydroxide is, and the molecular weight of calcium carbonate divided by CaCO3, aluminum hydroxide. Okay, and similarly for the second part, they have 20 into 2, because we know that 2 mole of sludge will form. Okay, so 20 into 2 into 78 divided by 666.5. Is it clear? I don't know why you, how did you get 4.5 gram per milligram per liter? If you want to discuss, we can discuss. How did you get 4.5 and 2.34? Okay, you can ask. If you have doubt, you can ask, or else we will move forward. Wrongly calculated. Okay, I hope this is clear to you. This is a very simple question. You don't have to do anything. The solubility product of magnesium hydroxide is 2 into 10 cube power minus 11 mole cube. Mole cube, it will be mole cube, dm minus 9 at 250 degrees Celsius. 20, not, just let me rewrite it. Okay, now. Hmm. The solubility product of this much is 2 into 10 power minus 11 mole cube, dm minus 1, that is decameter, decimeter, I don't know. At 25 degrees Celsius, the solubility of magnesium hydroxide in milligram at this temperature will be 20 milligram per liter, 10 milligram per liter, 5 milligram per liter, or 2.5 milligram per liter. Take your time, 1 minute, 2 minutes. It will, like, you have to calculate little bit. So take your time. This will last. I think if you have gone through assignment, some question might have. I don't know, similar type of question you might have found on your portal. Mummy, I am assuming that everyone is aware of how the solubility product is written. We know that KSP is equal to KSP. How we write it: S2S, SS, S4S, 3S. Okay, na. So task is very simple. Here they have given in mole. We have to convert into milligram per liter. Okay, na. So for dissociation, remember, initially when I was discussing, I said that how much, suppose B got one answer, B 10 milligram per liter. Okay, we will see. Okay, now. So remember, initially I made one point that amount of calcium added all depend upon the, like, what is the solubility. Okay, now. So by this, so now we know that we want to precipitate this thing. Suppose for any metal is there and we want to precipitate that, we can see that a certain amount of magnesium is required, certain amount of hydroxy, OH minus or hydroxide is required. So depending upon, if we multiply the concentration of those things, then we will have some KSP. Okay, now. So if your this amount which is added, if it is above that, after multiplying the both the amount, if it is above the product is above the KSP, then it is said that your product, your what do we call, your precipitate will form. If it is less than the that KSP, then it won't form. A particular term is defined for such thing, that is saturation index. I don't see that this has been. Let me see. Have anyone heard of this concept, saturation index? Hmm? Anyone anyone have heard the term saturation index? I'll show you what I was talking about. Like how it depends that which particle which will form, what will form, what won't form. It's all depend upon something called saturation index. See, we know that where does it end? Solubility. So see, this is our metal. It is giving M2 plus L minus. So Ksp will be this thing that is. Remember, generally we are dealing with concentration, but in actual, it is activity, and activity is different thing. Just for now, I will be saying this concentration only. Okay, na. So initially, what will happen that this KSP will be given as concentration of whatever is being added. Okay, na. And in actual, so this is general term, but in actual condition, we know like there is something called ionic. This is KSP that is at equilibrium condition, and this is Q at any time. Okay, na. So like suppose if equal amount of is not even added, like this is KSP is ideal condition, like not ideal condition, like it's like equilibrium condition. We know that reaction constant K and all this thing. Similarly we have Q. Okay, na. Q is at actual condition. So okay, na. So depending upon this thing we have Q. If Q, now see what I was saying, that whatever we have added, if the product is greater than if it is equal to KSP, then the system will be at equilibrium. Okay, na. If it is less than, if it is less than KSP, whatever we have added, suppose calcium and suppose here M2 and L2 has been added. I mean, its product is less than KSP, then there will be no precipitation, no solid. But if it is greater than the product is greater than KSP, then system will be supersaturation, and there will be precipitation of solid. Condition apply that kinetics, like rate of formation of solid. Remember, like for formation of any solid it takes some time. So if kinetics is also favorable, then that solid will form. Okay, na. So this thing I was talking about, saturation index, SI is equal to log 10 Q by KSP. Q is equal to KSP, at that time SI will be 0. If Q is less than KSP, under saturation index will negative, no solid will form. And if Q is greater than KSP, then system will be supersaturated with particular to that solid. Okay, na. And B can have solid depending upon the kinetics, and at that time SI will be 0. So this thing I was discussing initially also. Okay. So so now if B solubility, if we take as S. Okay, na. Then at equilibrium it is X mole, then it will be 2S mole. Okay, na. Because both are in reaction always occur and equal molar. If it is concentration is S, then its concentration will be 2S. We know that Ksp is equal to Ksp into concentration of these two into multiplied by this into this, depending upon the stoichiometry. Okay, na. So here the concentration is S, so we have kept S. OH minus concentration is 2S, we have kept 2S, and Ksp is already given 2 into 10 to the power minus 11, 2 into 10 to the power minus 11. Then from there we have found out that S is equal to this much mole per dm meter cube. Okay, na. Molecular mass of molecular mass of magnesium hydroxide is 24.3 plus. You can just use 24 also. Okay, na. Generally 24 is used. 24 plus 2 into 17, that is 58 milligram, 50 gram per. Sorry for the inconvenience. Actually, my internet connection was out. I don't know why. I'm sorry. I hope everyone is able to see my screen. I'm so sorry again. So at that time, I was discussing about how to write this KSP. Okay, na. So this will be written in the form of magnesium, and we have already assumed that the concentration of magnesium is S, then OH minus concentration will be 2S because it is both are in equimolar. So 2 into 10 ki power minus 11 is equal to S into 2S ki power 2S square. We have substituted the value, and after some recalculation we have found that S will be around 1.7 into 10 ki power minus 4 mole per dm cube. Okay na. Then we know that we already know that its molecular weight will be 24 plus 2 into 17, that will be 58 gram per mole. So we have to convert this mole into milligram per liter. Okay na. So 1.7 into 10 to the power minus 4 mole, to convert mole I have multiplied by in the multiply it with its molecular weight, that is 58 gram per mole, and we know that we have to report our answer in milligram. So we have converted gram. Here you can see that it is in gram. So we have converted gram by multiplying it by 1000 milligram divided by gram. So you can see the all unit will get cut, mole will get cut, and then finally we will have a final answer of 9.91, that is equivalent 10 gram per liter. I think some of one of you has reported this. Oh, all the chat has been disappeared. Okay, no problem, but all the chats are gone. I hope someone miss. I think those who remained in the chat might be able to see the chat. Might be able to see the chat history. But the correct answer is B. One of you have answered it. So good. Okay, so till now we were discussing. There are some more questions. Of before further discussion, just I want to take notes about the previous discussion. So there were one dot from assignment one. So did all of you got marks, or it's still in pending mode? So there were some problem in question in previous in assignment 3 and assignment 1. I have notes in assignment. Did you get your marks or not for assignment 1? I have already mailed them. I still miss. I have not got any reply from them. I'm hoping that they have corrected the mistake and you all of you have got your marks. And regarding assignment 3, again there was one problem that uh, got it. Okay. And what about assignment 3? Assignment 3. There was one problem that answer A was correct, but in spite of marking A, they have not given you marks. And similarly, many of no sir for assignment 3. You have not got any marks for assignment 3. Okay. So for assignment 1, it's all done. Okay, then I will like I have already mailed it, but again for assignment 3, I will send one small reminder. Okay, na. So just wait for wait for some time. You will get like marks for the assignment 3 also. So any more problem in previous assignments? Anyone? Assignment 4. What problem did you get in assignment 4? Let me open assignment 4 first. Just wait for 1 minute.
Sir, in assignment for question number two.
Just wait 1 minute. Let me open the assignment first. Okay, I hope you are able to see my screen. What's your what is the problem uh, uh, in live session option 3 was marked wrong, but here it's correct.
Question number two, sir.
Question number 2.
Yes, sir. Yeah, question number two, sir. Option one, T decreases as water quality decreases. According to PDF, sir, it was given T increases as water quality decreases. Something like that.
In live session option 3 was marked, but what is the correct answer is B, that is 134.
But option number one is incorrect, sir.
What
According
is
to PDF, sir.
as water quality decreases? Just let me check. I think this question was discussed also. Just give me 1 minute. Option 2 and 4 are correct.
Yes, sir. They have mentioned TE decrease as water quality decrease.
Yes. Sorry. Yeah, that is correct. This is like wrong statement. Only 2 and 4 are correct. 2 and 4, that is at high pH increases at and increasing bubble size, decreasing the bubble size.
Yes, sir. According to the question, none about should be answered, sir.
Okay, but here they have corrected given the 1, 3 and 4. I think this is wrong. Uh, Fourth one is correct. Decreasing the bubble size is okay. First is also incorrect. I think only 2 and 4. Again, here it will be the correct answer will be C. 2 is wrong. Independent of water quality parameter. Like no, sorry. 2 is also
Yes,
incorrect.
option number three is also correct, sir.
Only option 3 is correct. See, this is incorrect. But TE is dependent upon the water quality such as pH. It is dependent upon the pH. So this is also incorrect. Uh, This is also T increases as gas, not decreases. So this is also incorrect. So only fourth is correct.
Yes, sir. So that should be none of the above, but it's
No,
showing
none
here.
of. I think question number two, assignment four. Now, okay, I will mail regarding this. Question
Okay,
number
sir.
four only. Four is correct. Any more doubt in another? What about others? What was your name? Tenjin.
Sir.
Oh, what about him? Nayage. So we have marked none of the above because yeah, that miss. Yes, I think if you miss as per the question, E will be the correct answer because only four is and there is no such option. So everyone agree that E will be the correct answer, or anyone have another kind of doubt? Any other doubt? What about others? Okay, apart from these, any other problem?
No, sir.
I think, so. In last class, some of you have asked this question that RO member can remove all type of microorganism and viruses. So last time in the discussion, I said that this would be a correct statement, but it has been like see, miss like it's not entirely correct. Microorganism, it can under microorganism comes many things. So it is seen that reverse osmosis membrane cannot remove all the microorganism, and similarly for viruses. Okay, now there are certain type of viruses. I don't recall the examples, but it cannot remove all the viruses. Okay, so yeah, its answer is D124. Okay, now you can see this type of question were discussed in last class. Yeah, this type of you can always expect the same type of question as usual. I think here also in this time also you will be getting same type of questions. Yeah, here you can see same type of question, same type of question.
Hello, sir. And question
Same type of
5, 75, sir.
seven
5, 5, sir.
five. Huh?
Yes.
We have discussed this though. D will be correct answer. We have discussed few minutes ago. Uh, Here this question. You can see amount of LM required 20 into 3 into 100 divided by 666. We have just converted into milligram per liter. Similarly,
Okay,
the
sir.
amount
Thank you, sir.
amount of sludge which will form, it will be twice because 2 moles of for each mole of LM, 2 moles of sludge is producing. So 20 into 2 into 78 divided by 666, we have 4.68. So the correct answer will be D, 9 milligram per liter as CSU3, 4.68 milligram per liter. See, here they have directly written. I have in the solution. I have directly written it. Okay, na. So someone like if we someone just see it like this, then someone have to understand why they have written it 100. So if you recall the first year second lecture where I was discussing about alkalinity, then I have said that we have to multiply by it by equivalent weight. Anyone remember that what is equivalent weight? So if this is this was a objective question, that's why I've just simply multiply it and then wrote the correct answer. But if it would had been objective, like paper, pen and paper, then I have to thoroughly write like that this much mole is reacting with 3 mole. And here what is here out of this calcium bicarbonate, only carbonate is giving the alkalinity, okay na, not this calcium, this thing calcium. So first from here we have to find out the bicarbonate alkalinity, sorry, bicarbonate concentration. Once we know the bicarbonate concentration, we will be finding the equivalent of bicarbonate. And once the bicarbonate equivalence is found out, then we will be multiplying it by equivalent weight of calcium carbonate, that is 50. Then also you will get this same answer, 9 milligram per liter. Did anyone get what I said? This is not simple. Like here we have multiplied it because the valency is here also 2. The valency for bicarbonate is 1, but as it is 2 moles, so it will be multiplied by 2. I won't confuse you more, but just remember the how to find alkalinity using equivalent. Okay, na? So go through some books, maybe Swan and McCarthy. There is one book. I always suggest everyone that you can you if you are interested in wastewater, then go through this book. Where is that book? Tanisar Lab. Uh, hmm. This book explain this chemistry for environmental engineering and science by Sware and McCarthy. So this is really nice book for all kind of taste, hardness, alkalinity. Here you will get the taste which is done and how different type of conversion is done. And just read it. You will have an idea if you are interested in environmental engineering. I think if you are sitting here, you must be interested in environmental engineering. Okay, so this was all about previous assignment. Any more doubt from previous assignment? We have more 6 7 more questions. We'll be discussing one by one. So I am proceeding. So these are very small question. Just try to answer it as soon as possible. Which of is not commonly called in wastewater treatment? Very simple question. C. Yes, sodium chloride is a common salt and does not function as a coagulant in wastewater treatment. Coagulant like alum, ferric sulfate, polyaluminum destabilize colloidal particle, adding in the aggregation and removal. C was the correct answer. Which of the primary mechanism of coagulation in wastewater treatment? Adsorption, evaporation, ion exchange, reverse osmosis. A. Yeah. Coagulation works by neutralizing the negative surface charge of the colloidals particle through the addition of coagulants like alum or ferric chloride. This allows the particles to come closer and aggregate into larger flocks, making them easier to remove. What is the pH range does alum precipitate for phosphorus removal typically occur? pH range. This thing we have discussed. B. What about others? Yes, B is the correct answer. The alum, that is Al2SO4.18H2O, effectively works in the pH range of 5 to 7 for phosphorus removal. It forms soluble aluminum hydroxide which precipitate out the solution. If the pH is too high or low, the efficiency of precipitation decreases. Which of the factors significantly affect the efficiency of coagulation and flocculation? Particle size and charge, color of the wastewater, smell of the wastewater, presence of oxygen. A, yes. The size and the surface charge of the colloidal particle determine their stability in wastewater. Smaller size with higher surface area resist coagulation. Coagulant work by neutralizing this charge, allowing the particle to aggregate and settle. And also, if the particle size is very high, then it will just settle on its own. There is no need to add any coagulants. Which of the following is commonly used for heavy metal removal for from industrial wastewater? Coagulation, chemical precipitation, sand filtration, or chlorination? B. Chemical precipitation. Yeah. Chemical precipitation is widely used method for removing heavy metals from wastewater. It involves adding chemicals like hydroxides or sulfide to form insoluble precipitate, which can be then removed through sedimentation or filtration. Which of the following best describe the role of polyelectrolytes in wastewater treatment? If you recall the PDF, they have discussed what is this polyelectrolytes. Yes, the correct answer is B, that they enhance the flock formation by bridging the particles together. Polyelectrolytes, also called flocculants, are long-chain polymeric molecules that help aggregate a small particle into larger flocks by forming bridges between them. This improves the sedimentation and filtration efficiency in wastewater treatment. Why calcium hydroxide is sometimes added along with coagulants like alum or ferric chloride in wastewater treatment? A. Okay. A. Huh. Correct answer. So see, if you recall, I don't know here whether I have written the aluminum. I will show you one reaction. What really does happen when alum is added? So here it's not written, but okay, the answer is correct that it will be A. But I want to show you one reaction. Like what does how why there is a need of alum in if you read someone if someone is reading Nalgonda techniques, there also you will see this thing that people are adding alum then lime, that is calcium hydroxide. So what happened that when alum is added, it releases aluminium 3 plus, and this aluminium 3 and along with this there is a release of H plus ions also. So what happened that overall pH decreases. Okay, now so to neutralize, and we know that for flocks to occur, the what do we call the minimum pH condition required is between 5 to 7. So I think everyone is able to see my screen. Here you can see this thing. Okay, now so this when alum is added, it is forming aluminium 2 plus, and aluminium 2 plus is reacting with water, leaving H plus concentration. And what will happen that this H plus will lead into decrease in pH. So to neutralize as pH is low, to neutralize the pH, and so that a proper attraction can happen between the surface of aluminum hydroxide and fluoride, the pH should be maintained between 5 to 7. Okay, now for that this calcium hydroxide is added. In your question also same thing is happening, and I discuss this aluminum ions leads to neurodegenerative disease. That's why this method is not used. So this was extra information. So yes, correct answer for that question was uh, uh, to increase the alkalinity and enhance the coagulation. When the LMF add, it reduced the pH. Why it reduced the pH? Because there is a release of H plus ions. Lime is added to maintain the optimal pH method. Okay, na? Huh. Uh, uh, why? Again, it will be 18 number. Okay. So this is one last question, not last question. There is one numerical question after that, but in heavy metal precipitation, why sulfide precipitation preferred over hydroxyapatite precipitation in some cases? Sulfide are more soluble than hydroxide, making them easier to remove. Sulfide precipitation forms more insoluble metal compound, reducing metal ion concentration. Sulfide precipitation require no chemical dosing. Or sulfide precipitation is faster than hydroxide precipitation. Answer it. Anyone? B. Sulfide forms more insoluble metal compounds, reducing metal ions. Yes, I think this is the correct answer. Let me see. Yes, B is the correct answer. Sulfide precipitation is preferred in case where very low metal concentration are required. Metal sulfides such as PBA, cadmium sulfide have much lower solubility than hydroxide counterparts, allowing them for more effective heavy metal removal from wastewater. I hope everyone got this. Simply, it forms very stable and insoluble metal compounds. There is one numerical question. The wastewater treatment plant is using LM, that is Al2SO4 whole thrice dot to remove phosphorus. The phosphorus concentration in wastewater is 8 milligram per liter, and the required molar ratio of Al2P for precipitation is 1.5 to 1. Like however, for each mole of phosphorus, 1.5 mole of aluminum is needed. A plant treats this much of wastewater, determine the amount of liquid alum 40% by solution, nearly density 1.2 kg per liter required. So first, how much alum you have to add if you want to precipitate phosphorus, and the required sludge storage capacity for MISA. Uh, like for 30, if you want to make a storage capacity, then what will be the volume of the storage, so that um, it can work for 30 means like in a simple way we can also say that amount of sludge produced in 30 days. Okay na? So I will be just directly answering it. First, we will find out the weight of aluminium required. So aluminium strength solution is 48%. Whatever we are adding, only 48% is alum. Okay, na. Density is saying that 1.4. This is given. Density is 1.2 kg per liter. So alum per is only 0.48 into means only this much of alum is coming. That is 0.576 kg per liter. Pay attention. Okay, now if you have any doubt you can just ask me to re-explain. Aluminum content, now we know that molecular weight of alum is this much. Aluminum content will be, from here you can see that each mole of alum contain 2 mole of aluminum. Okay na? So the alum content will be 2 into hmm, alum content in alum will be 2 into molecular weight is 27, but here it is written as 27.98. You can consider as 27. 27 divided by 666 means for per kg of aluminum this much kg of alum is coming. Sorry, for per kg of aluminum 0.018 kg of aluminum ions are coming. I hope this is clear to you. So we have to find the aluminum required per kg of phosphorus. The atomic weight of aluminum is 27. Atomic weight of phosphorus is 31. Okay, now theoretically it say that um, um, uh, so in question it is already said that for one for but like for 1.5 the molar ratio of aluminum to phosphorus is 1.5 to 1. So theoretically you can see that aluminum per p is 1.1 into 20, like suppose there is one gram of yeah, aluminum. Okay, na, so it will be 1 into 27.98 divided by 31. So you can say that per kg of phosphorus we have 0.87 kg of aluminum. We have already know that the molar ratio is 1.5 to 1. Okay, so the actual aluminum required is 1.5 into 0.87, that is 1 point. So this was theoretical, like if we have 1 is to 1 ratio, but as ratio is 1.5, then the amount of aluminum per kg of phosphorus will be 1.305 per kg of phosphorus. Okay, so we have already found out these two things: what is the aluminum content in lm, the amount of lm per phosphorus. So like so for per kg of for per kg of phosphorus this much of lm is required. Okay, na, and we also know that for per kg of lm this much of lm this much of aluminum is obtained. Okay, na, so to find out per kg of phosphorus we will just divide those two values. The lm required per kg of phosphorus, the amount of aluminum required for phosphorus divided by amount of lm produced in per kg. So we can say that for per kg of uh, for to so this much of lm is required for per kg of phosphorus, that is 16.11 kg of lm per kg of phosphorus. Now total phosphorus, we are seeing that this much of water is flowing, so to phosphorus concentration is 8 milligram per liter, it is given in the question. Okay, na, 8 milligram per liter. So total phosphorus will be this much kg. uh, Total phosphorus will be 96 kg phosphorus per day. Okay, so total we have already know that for per kg this much of lm is required. So for this much kg of phosphorus, how much of lm is required? 1546 kg per day. Okay, so the amount of liquid required, we know already know the we already know the density. So the amount of liquid lm required will be uh, this much divided by density. Density we have already calculated the lm, miss, lm, that is 0.576 liter kg per liter. So we will be dividing it. We already know that total ammonium required per day. The volume of the lm required per day will be this much divided by this much. This liter kg will get cancelled out. So this much of this much liter per day of liquid lm is required. So lm storage capacity for 30 days will be this much into 30. That is 80500 liter. Okay, na. Hmm, hmm. Anyone, any doubt? I Did you get it? What I just explained? This similar type of question is in your material. You can, if you do not get, if you have not got it, this ppt will be uploaded on the Google Drive link by today only. You can check it. If you have doubt you can ask it. And regarding your assignment 3 and assignment 4 marks, just give some time, wait for some time. I will make sure that all of you got your marks. Apart from these, any other doubt, or we can in this session?
Hello, sir.
Yeah.
Sir, do you know how will be the exam pattern for certificate?
That I have no idea. Sorry, I have no idea about that.
So this assignment mark an exam with my whole direct.
Sorry, sorry.
This assignment and exam mark will be directly related to our this grades in college.
Yeah, I think that it is written in your this here. I think for your final examination, something is such condition is maintained that if you want to get like there is a category now that this golden then silver. Miss, I might be wrong also. I have not gone through it. I will request you to go to through internet only. There you will find out what is the terms and condition to get just examination reminder. This is examination reminder. Miss, sorry, I cannot help in this thing. I have no idea about this. Anyone have any other doubt? If no, then I am ending the session. Let's meet on next Tuesday. That is on 4th of March, and this time most of you were active during the question and answer session. So that's really good thing. So I request you to be active in the upcoming session also. So that's all for today. Good night.